Hello, this is Panic Consulting's ArcGIS workshop. I'm Frank Conkling, and this time what we're going to do is we're going to look at ArcGIS Pro and the geometric construction tools. I'm going to go a little bit old school here. Normally we talk about some of the more advanced topics with parcels and parcel fabric. This time it's just what tools do we have in ArcGIS Pro and how do we use them? Before we do that, let's talk about just sort of Panic Consulting. We are an ESRI business partner, have been for over 25 years. In addition to the release ready specialty designation and the state and local specialty designation, we are the first company in the United States to get the parcel management specialty designation. We specialize in the parcel fabric, and hopefully, if you're interested in it, want to know more about it, you'll reach out to us and find out who we are, what we do, and give us a chance to go and do something. If you look at the QR code in the lower right corner, that will take you to our website, where in addition to information about us, you'll see a link in which at the bottom of the homepage and the bottom of the workshop page, in which you can sign up for our monthly newsletter and get links so that you can attend live these workshops and ask questions and comments and things of that sort. If you are attending live, thank you for being here. We really appreciate it. And thank you for everything you've done to help us with this. But if you have a question or a comment, go ahead and put it over in the chat window, and I'll go and look and I'll make sure that I get and pay attention to it as we're going along. All right, so today, what is geometric construction? Why is it different from what we usually talk about? We usually are talking about COGO, coordinate geometry. Coordinate geometry is when you derive the actual location of a line or a polygon or anything of that sort by calculating the positions of the vertices or the points using trigonometric functions, things such as going for a certain direction and distance, that sort of thing. We're not talking about that. Today, what we're going to do is, again, we're going to go back to even further, no COGO, but we're going to go and look at ways in which inside of ArcGIS Pro, you can draw lines, you can draw polygons, and you can use and reference existing features to create new things by capturing the geometry that's on those new features. That's the reason why it's called geometric construction. You are capturing the geometry from other things, or you're using your current geometry to create something else new. So real quickly, here's a couple of examples that we're going to go through. And these are the constraints. These are things that will, as you're building, it will help you to go and use this geometry that you're capturing for things like creating something parallel or perpendicular or deflection or a segmented deflection. We're going to explore that a little bit. Or the distances, or inputting circular curves or spiral curves. In addition, later on, we're going to look at other types of construction: copy parallel, extend trim, continue feature, line intersect, fillet, array, mirror, offset. These are all ways that you can go and use the existing geometry of something else to go and create something new. All right, let's get in here. Just a simple feature class. I've got two here. One is sample lines and one is parcels. We really are not going to deal much with parcels. It's just going to be lines today. Almost all lines is what we're going to do. These lines themselves, I don't even think they're COGO lines. I think they're just normal lines. That's all. Let's see. Nope, it's just normal lines. That's all they are. There's no COGO, nothing on them. So let's look real quickly, and I'm just going to go in and real quickly just show you the construction tools that are available for lines. In this case, this first tool here is create a line feature. Now, this line construction tool is actually what used to be called a polyline. This is a multi-vertex line in here. So when I draw it, it does not finish until I actually go and double click on here to go and show you. And again, this is one of those tricks with Pro. We'll go in here and we'll just look at and create some markers on here, in which we'll actually go and display sort of things such as, we'll go and we'll show you where where the actual vertices in the middle of the lines are. And let's go and change this down to a smaller size. And we'll put these on the vertices. And then we'll go up here to this one and we'll change this and make this red and show you that there is a difference inside of here. There'll be multiple vertices on here. And we'll put these at the extremities of the line. So when we do this and symbolize it in this way, it allows us to see that there is, in fact, multiple vertices on this line, this one type of line that we just used to create. And again, this is a polyline, or the multi vertex line that's in here. There's also a right angle line, which allows you to create right angles with the line feature, so that we can immediately, it goes and constrains us to right angles associated with that line. We can then use that, and then it constrains us to the next one on here. So this is a good way to go in and create lines that are supposed to be perpendicular or at right angles. Maybe you're going and mapping a building or something of that sort, and it's a good assumption. There's also a tool here. This is the split tool, in which we go and draw a line here. And when we draw that line, what that line is going to do is it's going to go and split the other lines that it goes and intersects, built in, so that you can automatically go and build in, and it will split those lines, those other lines that it goes and intersects, but not itself. So if we go in here and do this and use this line, it automatically, again, will go and split the line that you cross or intersect this with. Nice tool if you know that you're going to do an intersection eventually, a planarize or something of that sort. This is a radial line in which it does a series of line features originating from a single point. All right, so if you'll note, each time I do this, it automatically goes back to my beginning point. So if you come across a time where you have to go and set the one point, that the origin point, and then everything else comes off of that, this radial tool on the construction tools is actually a very nice tool to go and use that on. The one that we use most often, go ahead and apply that. The one that we use most often is, in fact, this 2-point line. And again, a 2-point line is one in which there is it ends every single time you go in and finish this, it goes and puts an end to it. Now on here, on all of these, as a matter of fact, you also, by the way, let's finish with this. This is a freehand line. Once you start this, it goes and follows you, and it will go and put a vertex at the settings for this. And then here is the trace line, in which is going to let you trace it out, and then go ahead and trace this as you go around. And let's go ahead and finish that line. So those are the basic tools. But on all of these, you have other options. You could go to your option button here, and it will show you that, for example, on this 2-point line, you have the ability to once you create one line, it will allow you to go and rubber band beginning at the end of that first line you created. So when I click on this, this will be the default. I can create a line, and it automatically will let me to continue with that until I actually go and tell it to create a new one. Then it will go and continue with that rubber sheeting, and that is the continue 2-point line. That default, by the way, is set in the feature template as far as whether or not that's part of your continue setting for this. So simple lines, creating them. We have a series of tools that are used to create them, depending upon what you're doing with it. Whether you're going to have multiple vertices as part of it, that's this first one. Whether or not you're going to be creating lines that are perpendicular or at right angles to one another. Whether or not you want to split the lines, the new lines that you're creating. Again, when I go and do a split here, it will go and split the other lines that are existing here. Whether or not you want to do radial, 2-point line, freehand, or whether you want to trace something else in here. So these are just, again, standard lines. And while we're constructing, we have the ability to go and, depending upon the tool, use them to sort of control what gets constructed. In addition to that, we have what's called constraints. And these constraints kind of like work like that right angle one. It constrains or limits what you can build off of this. So if I have a line here and I wanted to go parallel to this line here, I could use this geometry and I could right click on here and say parallel to this line. If you notice, it automatically flashed blue here, and then it allows me to go and construct my next line parallel to that line. I could do it here by going right click and doing parallel. Note, by the way, the keyboard shortcut, I could actually just have typed in a T or a P here, and it would then be parallel. Again, I could go over here, type a P, and then parallel, and I could go from there. What happens if I wanted to go perpendicular? If I go over here and right click to show my possible constraints, I have perpendicular. And again, my keyboard shortcut is E. I could go perpendicular to the one I'm selecting on, and that allows me to be 90 degrees to whatever I was on top of when I selected that. So that's parallel and perpendicular, and they have keyboard shortcuts associated with them. Let's go and start another line here. And let's just start this line and look at what other constraints there might be. There are in fact, distance constraints. There's also a direction constraint. If in fact you know what a bearing is, that you want to go and make sure that it's on that bearing. If we go and input that in, I can then have a bearing on here, say it's 45 degrees northeast. All right. I have that, and I'm now on here. When I go and hit enter here, my line, as I'm building it, will be constrained to that bearing that I input. I hit the escape key to sort of pull that constraint off on here. And now I'm going to look at other constraints. So far we've looked at parallel, we've looked at perpendicular. Let's look at distance. If I know that my next line is going to be a certain distance, it's supposed to be a certain distance, I can type that distance in here. Maybe it's 400 feet. With these constraints that you have an input on, once you type the value in and you hit enter, it then constrains it so that it only will allow you to go and input on that constraint. So again, I now am actually, it's letting me see sort of the values or those places where it's 400 feet away from that last point that I went and clicked on. And once I click on the end point for my line, it then goes and releases the constraint and allows me to continue working with it. So again, that's the distance constraint. When I click on this again, I have absolute X, Y, and Z. These are constraints that allow me to go and input a value if I know what the coordinate value is for my next point. If I have some sort of indication, maybe I have a subdivision or a survey that tells me my next point is supposed to be at a certain value, I can input that in. Delta XYZ means, delta, by the way, being the Greek letter, but basically it's interpreted as being the change. How much of a change is there in X, Y, and Z from the current value that you have? So if I put delta XYZ, I can say that this is supposed to move 150 feet, and this is in the X value. So the X value is horizontal. The Y value is vertical. So I can say maybe this is supposed to be 250 feet. So in the X, it's going to be 150 feet in a positive value, 250 feet in a positive value, and the Z value I'm going to put as 0. When I type that in, you will find that this is 150 feet over, 250 feet up, and that's my DX, Y, Z. That is my delta XYZ on there. And sometimes it's useful. These tools are, you could consider these just sort of tools in a toolbox. You're not going to use them all the time. You will wind up having favorite tools and you'll use them all the time, but other times you may only use them every once in a while. But it's a good thing to remember that you have these in here. Direction and distance. This is, again, bearing and distance for those of us that are in the US, bearing and distance, in which you tell it, and it uses Kogo to go in and determine where the next point is supposed to be. I'm going to go, before I jump to the circular and spiral curves, I'm going to show you there's also another one here that we often forget about, in that while we can set the snapping values down here under our snapping, let's go and escape out of this here. And under snapping, we can tell it that we want to snap to sort of the nearest point or the nearest end point or the nearest vertex. These are all sort of points here. Or the nearest edge. This is snapping to an edge. This is snapping to an intersection. This is snapping to a midpoint. This is snapping tangent to a curve. Well, we have these snap functions in there all the time, and usually we're working with them so that as I'm coming in here, I can see it's snapping to the edge, and there it's snapping to the midpoint. Here it's snapping to the endpoint. I also have this option, snap to feature, in which I can tell it the same sort of thing if I'm close to it, and it will allow and then automatically snap it and finish my drawing of that line. So again, I can go here and say, snap to this feature, snap to the endpoint of that feature. It automatically will snap to that. So it's a really useful, constraint in here. And all I have to do is get close to it and then say, snap to the endpoint of the feature, and it automatically will finish that function out. A lot of us forget to use that. And that's really, really useful when we're building things. Often we'll just go and try to snap to the point, but we can go and use that snap to feature. And it is, again, super handy. You go in here, you just say, snap to the endpoint of that feature, and you're automatically snapping there. All right, let's go and start another line in here, just sort of to remember what we're doing. And we'll do this. And so the next couple of constraints that I want to talk about are the circular arc constraint. This one replaces a lot of the functionality in ArcMap, in that it allows us to go and see circular arcs. And it starts out by it automatically, if you've got a line drawn in there, it automatically will go and take the line and assume the bearing of that line, the direction of that line, and use that as the tangent bearing. Tangent being that it's going to be perpendicular to the radius point, no matter which side it is. And it allows us to go in and input, for example, a radius distance on here. Now that radius distance, we can go and tell it, for example, whether it's to the left or right. Well, on the circular arc constraint, we go and we tell it using this, whether it's to the left or the right. We also have the ability to go and pull down and give us different parameters. Let's say we wanted to have a 90-degree curve. And if you look, one of the advantages to this constraint is that it allows us to go and see how far and what this curve actually looks like before we actually build it. So it's got built in the sketch, so there's a preview built in for us automatically. It's a really nice tool, and you can actually use this in conjunction with the traverse tool, so that as you go and build this and put this in, and if you hit enter, it then goes and builds the line. And if you're dealing with the traverse tool, it actually goes and populates that row on the traverse grid for you. So it's a really nice tool there. There's another constraint here that deals with curves. and that is the spiral curve tool. Spiral curve's a little bit more obscure in that a lot of people don't use it. As surveyors, we're used to using it. Spirals are used to describe, for example, curves in which you can't have a very sharp transition or change. It has to be a very smooth, very slow transition. So things like railroad rights of way have spirals on them. High-speed interchanges, overleaf interchanges and stuff. If you think about it, when you're driving and you're getting ready to exit off, usually you will go into a curve. And if you'll notice, that curve changes how sharp it is as you're going along it. The beginning of the curve is very flat. And then as you get further and further into the curve, it gets sharper and sharper and sharper. That's a spiral. That's a spiral curve. So it's similar to having a regular circular curve, except it has a changing radius as you move along it. So in this case, we have to tell it both the beginning and the ending radius for this. So in this case, we're going to say we started as a straight line, and then by the time we get done, we're down at 200-foot radius, and the arc length in this case might be maybe 300 feet. And if you'll note, and let's make it to the right, and we can densify it by how often this goes and does this. Let's do it by the length and do it every 50 feet so we can see some variation on it. This densification is the way that Esri goes and approximate what that spiral actually looks like, because they have no true primitive graphic for a spiral, but they get it as close as they can. And the densification just sort of shows and tells them how often do you want to drop a vertex on that spiral to go. Let's change this a little bit more. Let's change this radius to 100. So you can see how it's actually increasing that as it's going along. But every 50 feet, it's putting a vertex in there to approximate where this spiral curve actually goes. So again, it allows us to define what's the tangent direction. Again, we can make this chord direction also. What's the starting radius? What's the ending radius? What's the overall arc length of it? These are all things that you get when you're laying out a spiral curve. And then what side or which way is this thing changing? And then how you want to densify it. When you hit enter, we then wind up with a single line feature. That single line feature, let's go here, single line feature actually goes and has the arc length on there and such. Because this is not Kogo, it doesn't store any of that, but it actually, that is a spiral curve. Really interesting. If you're ever dealing with spiral curves, it's a nice tool that Esri's finally put in here, and I'm really thankful for it. So let's go put another straight line in here, and let's talk about another way that we can go and resolve this. So where is our deflection? There is a segment deflection here in which I can go and why is this not? Do I have to be here? Segment deflection draws a segment specified angle from the one. So where is it prompting me for the angle? I don't see that prompt on here. So there should be a deflection in here. There should be a segment deflection also on here. I'm trying to see why it's not here. Let's finish this off. Does it matter which type? That's exactly what I'm thinking. It might matter as far as which type. You can see I have reverse direction. I have changed length here. I have replaced curve. I have streaming, but I don't have the actual deflection. The deflection actually, segment deflection, it should be prompting me, and I don't see it prompting me on here. So it might matter. It might matter also whether it's a cocoa line or not a cocoa line. Change direction. If you'll note, I have here a line that I've drawn. The green square is the beginning of the line. The red square is the last point that I put in place. And if I look at this, I can tell it to change which is the beginning and which is the ending, or change the direction in which this is going on here. Let's go in here. I can also change the length on here, in which I, instead of being 402 feet, I can make it 450 feet as I am editing this and inputting this. Let's see what I've covered here and what I haven't covered. So we looked at parallel, we looked at perpendicular. The deflection, I'm not sure where that is. I use the deflection in traverse. Segmented deflection is interesting. I think both of these, you might need Kogo lines on here. Distance, actually, we looked at circular curves, spiral curves. These are all constraints that as we're building, it goes and keeps us from doing anything else. Let's look now at some of the tools that once we have something built, how do we go in and use other information to go and build on that? So let's go over here. Let's go and start with just a simple line. I'll double click on that. If I go to my modify, all right, there's a series of tools here under construct. First one, let's look at copy parallel. Copy parallel, you must have a line selected, a line or a series of lines, a chain of lines selected. And if you go through here, it's like, what are you going to build? In this case, I only have one line feature. And how am I going to build it? I only have one, so it doesn't give me an option here into whether it's separate features. Let's change our selection. Let's do this. Let's select it to this one. All right. So now, let's also get rid of that polygon. We don't want parcels here. Now these two lines, they give me this option that if I have more than one line selected, more than one feature, I can either copy them into separate, in which case that's going to be one line, that's going to be one line, or copy it into a single multi-line in here. The next options as I go down through here for copying parallel, what is the distance? Let's say I want to go and make this a distance of, let's put it 100 feet. All right, 100 feet. Then how many times do I want to repeat it? In this case, let's do one. And then do I want to repeat it on both sides of the line, or just the left side of the line or the right side of the line? All right. Now, again, it's going to, that right and left is going to be determined by the flow or the way in which those lines were originally created. It stores the beginning point and the end point when you create it, and it's going to use that to figure out which way it goes. Let's go do both sides. All right. And then we have other options. What about the corners in here? How does it handle those? Are those rounded? Are those beveled? Are they mitered? Does it have self-intersecting loops? Does it store those or not? Or remove them and align the direction of the connected lines so that they're all the same? In this case, I've told it to do it as single line. Let's do it in separate lines so that, and notice, because I am symbolizing it that the red is the end of the line and the green is an interim point, you can see that if I do it as a single, there's a green, that's going to be a vertex. But if I do it as separate, those are actually separate lines that are going to be created. Again, I can change how far apart, how many times I make this, how many times I do the paralleling on here. All right. And I could just go and say copy it. Nice tool. It copies them all at one time. They are separate lines because I told it to do it as separate lines, and they are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 of those lines are being created at the same time. Again, using existing geometry to go and build this new construction on here. Copy parallels, very nice. So if I had a line in which maybe I had a distance that was measured off of this line, I could select that line and say, I want to go and build a line that's parallel to this one. All right, copy parallel. I want to build that line, and it's supposed to be 49.67 feet only one time, and it's to the right side. I can then go and automatically create it parallel to that and use that as I'm going in and building this. Well, there's other things, for example, that let's go and build a couple others here. All right, that is the copy parallels. There's an extend and trim. What happens if these two don't fit together, but you want to use those geometries again to continue to construct this? So in here, there is under the modify, there is an extend trim function. All right, and that extend trim function, what's nice about it is that we can tell it in Pro to extend and trim this without having a selection. Let's get rid of our selection and say, let's extend and trim this. And as we go in here and look at, oh, you already saw it, didn't you? As I went over that line here, it actually had a straight solid line here and said, I'm going to go and extend that line until it goes and meets the other line. So if I have that indicator there and I hit the left button, it will go and extend that line. On this one, it will extend it over to here. So let's go and extend that line first. Okay. Note, and the way I symbolized it, it does not actually move that vertex. It literally left that vertex in there and just extended the line using that same direction. It's the same line. It's a single line here. If I go in here, that's a single line, but it left the vertex there where the original location was. And that's fine. You know, if that, just know that that's what it's doing on here. On the trim, the same way, if we go and do this here, as I move over, it gives me a dashed line, and that dash indicator says that's going to get trimmed off. So when I go and do that, it will get trimmed off. Note, it leaves nothing here. It just trims the line down. And note what happened with it within here. And I went in here in this space here, I went over the end of the line and it said this line can be extended all the way out to there if that's what you want to do. And that's, you know, it's a really nice tool to be able to go through here real quickly and just extend, trim, extend, trim, extend, trim, just looking at it, not having to select it. Just make sure that this works. What happens when we have something like this? And I go over these points and I want to extend them so that they can go and intersect and create a point out here where there's an elongation or an extension of these two lines. How do I do that? Not the extend trim tool. The extend trim tool have to go and intersect with their existing lengths. They cannot be, oh, I'll let you go and do this under the extension. And here, this line actually could go and intersect another line. This could be extended and match that line, but it cannot be here to here. That tool is called a line intersect tool. Line intersect tool, again, there's options, as with Pro. I can recalc the Kogo attributes if I had them, or I can create new lines when intersecting, which means one option will just extend this until the intersection. The other option actually creates a new line here and a new line here. Depends upon what you want. In this case, I'm going to go and initiate this tool. Say, okay, I want to extend this line with this line. It will go and show me where it's going to extend that line and intersect them. Again, note what happens. It inserted a vertex there where the original point was and just extended those lines. If I go and undo that and say, well, let's create new lines here and go intersect, intersect here. It created two new lines there where they intersected. Which way is right way? It really depends upon your case, whether or not you need to create new lines here or whether you just need to extend them. That's up to you to evaluate what and how you use the tool. It's in your toolbox. It's a really great tool. Helps you a lot of times to go and figure out what you need to do. But just be aware, there's options. I can undo that and do my extend trim and say here to here. There it is there. And have one line that's supposed to be at that two intersections. All right, let's look at some other options here. That's the extend trim tool. What about the continue feature? This is a tool that we have. Let's go and select the line here. And this tool is under continue feature. And basically what this does is it tells you that here is your existing feature, and I can go and extend it and continue it. All right. The question is, how long do I want to continue or extend it for? In this case, I'm just continuing this feature, and it's telling me what the distances is here. The distances are here, the X and the Y's of these on here. Change my selection or continue this feature. And so what is it actually doing here? If I'm looking at this, let's clear this out. If I look at it, it's taking this one line and added vertex here and put a new vertex here, the new vertex here. So it's taking the line and forming a multi-line or a polyline, and it's just extending this line and allowing me to go and make it multi-part. Continue the feature. I can then go and, it's going the wrong way. Maybe I'll use a tool I looked at earlier and change or reverse the direction so that it starts here at this end and use that. Again, learn to use the tools in here. There's a lot of tools. There's a lot of things that you can do. Again, the symbology helps us to see what's really doing. This is one endpoint of this line. This is the other endpoint of the line. And these are individual vertices within here. All right, one line. What else do we have? We have continue feature. Line intersection, we showed you already. This one really helpful when you're constructing things that you might use and maybe they don't intersect, but they're supposed to be intersecting. We go and do that. Let's go in and look at something here. So this is perpendicular in here, but let's assume that in fact that's supposed to be a curve. There's supposed to be a curve in here. Maybe it's a road right away or something. We can go in here and look at the fillet tool. Now the fillet tool or the fillet tool is actually it. We can actually click on a line and click on another line, and it will allow us to go and draw a curve in here. And it automatically will do trimming. It'll trim back to where that curve intersects. We can right click and say, well, let's go and find out and do it at a fixed radius. In this case, maybe let's say 100-foot radius here. Now, when we go and do this, it allows us to go and put that in. If we move our cursor, it allows us to change the quadrant in which this fillet occurs. In this case, maybe it was supposed to be where those two lines were, or maybe it was supposed to be an extension of that vertical line. Maybe it was supposed to be over here or over here. Do it here. Notice it extended that line and it put here, trimmed that vertical line in there before that. Let's use that same tool over here say, let's go and put a fillet there. It will go and trim them back to there. So this tool allows you to go and take a curve and calculate where it's supposed to be as it relates to a certain number of lines. So again, I could say I have this checked beforehand. I can say, well, this is supposed to be a 25-foot radius on this, and I can click here and here, and say, there it is there, and it automatically would trim it up. Again, here and here. I look at some of the tools we had in ArcMap and what it would actually take to do this. It's a lot faster, a lot better, and it will do the trims and such for us automatically. So that's the fillet tool. Let's look at a couple others that you don't use very often, but they're actually kind of nice tools. So let's go down here. Select this line here. So the first tool we're going to look at is an array tool. This array tool allows us to go and take this and build an array, as it describes, an array of these tools. And will show us how these rows, how many rows it's going to build of these. In this case, let's do 100 feet. And notice what it's doing is taking that and copying those values 100 feet, and it's doing it twice, or it's doing it 3 times, 4 times. Let's change this to a negative 100 feet so we can see it a little bit better. Taking this line that we have and copying them down below it, and we tell it how many times we want it to copy it. That's the rows, northing and easting. Well, how about here? Let's do this 50 feet, and you'll notice taking that same one and copying it 6 times up and down and doing it this way. So it's allowing us to copy that geometry and multiplying it and defining how many times we copy it. Here's an interesting one. What about levels? What happens if we have something vertical in here? It allows us what the offset is and how many times we wanted to go and do this. I'm not going to do that on this because it really isn't. I could also tell it a rotation. So maybe this is supposed to be rotated 45 degrees in here, and I can take it and rotate that 45 degrees, and it will build that whole array from whatever geometry I have and go and rotate it and build it the number of times that it's being calculated. So let's see if we can think of an easy way to go and do this. Let's go and create a little right angle here. Again, I'm right triangle. All right. Go and do this. Oh. Oh, wrong endpoint. Go do this. That's good. All right, so I have this. Let's go into an array here. And again, it remembered all the array that I had before. Let's go and say, well, maybe this is supposed to be just 1 time, and maybe it's supposed to be 400 feet there, and maybe this is on here. So it's actually copying this. Copying this value, this feature, multiple times this way. Again, I have it right now with a rotation. Maybe I don't want it to be rotated. And I can set how many times this same value gets rotated into this array as I'm going and building it. All right. Again, limited cases in which we might use this, but this is actually a very interesting tool, especially if we were building like a series of condominium units inside of a building or something like that. And once I click OK or the array on here, it actually will build it and select it all for me. I could just go and copy it, select those, copy and paste, and snap them as I want. But if I've got something where I've controlled where that array is, that might be a good way to go and do that. All right, let's go and do one more thing, and this is going to be, that was the array. We're going to do a mirror, and then we're going to look at the offset. So a mirror, let's go and create something. Let's create a line here. The mirror tool is interesting because if we go and click on the mirror tool here, again, it kind of looks and tells us how we want to go and do this. And we can click it and say we want this to be perpendicular. And
I wish I was an unethical money grubbing.
so let me go in.
I'd be richer and happier.
There. Okay. So if we look at this, it's actually allowing us to sort of identify where that mirror is actually located. And again, I could do it with a single click or double click. Let's do a single click one here, in which I take this and I say, that's going to go and mirror this exactly as I've selected it. Ooh, so think about it. If I go and create a unit, if I create something here, I can then tell it to go and mirror that unit there. Boom. And I can go in and tell it to mirror that unit there and mirror the unit there on here. So it allows me to go and take this and mirror it and pretty quickly go and reproduce that geometry over and over and over again. In this case, just sort of by identifying where it is. Think about it with the 2 clicks, you actually tell it here, and then where your mirror is actually created, you tell it where to go and create this, and it'll go and decide how to go and do that mirror. Whether or not it's perpendicular or not, you can go and mirror this with 2 clicks again, and go and do it that way. The mirror tool is a really, really interesting tool for constructing geometry with some control. Again, tools that we talked about today were really nothing more than taking existing geometry and using that to create something else. Got one more tool here. One more tool. Let's go back to create a line. This is the offset tool. So let's go and create that line. And let's just look at the attributes of it to see. That's about 1020. So this tool is very interesting in that the offset tool itself, this tool allows us to define that this 2-point line is what it is. And it allows us to say what the beginning point is. Let's say we start at 0 here and we end up at, we said it was 1020, something like that. That's the end point here. So that's how far it is. And the reason why we do this is so that we can set a scale up in here. But let's say we start there, and now we start creating a drawing and say we want our first point to be 100 feet up, and we want it to be on that line itself. I hit enter. Then I want this next one to be 100 feet up, but I want this to be, let's call it 75 feet on the right side. I can hit enter on here. I could tell it now 200 feet up, 75 feet on the right side. Make sure I really zoomed in here. Tell it to go and do that. Should this be 0? Let's try that. I'll set 0 on the right side. Wondering why it won't let me go and do this here. By feature, duh. Sorry. if I did it interactively, I would have had to draw it. So in this case, here's the starting point. Here's the ending point. I then tell it I want to go 100 feet up, 75 feet over. This is my next point. I'm going from that point, 75 feet over, to 100 feet. So I'm now going and building this from my previous point here, and I'm using references to here. So as I move further along here, let's say I want this next endpoint that I'm going to go build. I want this to be 500 feet up, and I want it to be 100 feet over from here. Let's go 500 feet up and 100 feet over. All right. So what it's actually doing is it's measuring the geometry from the offset, measuring the geometry from this. In engineering and surveying jargon, this is actually our baseline, measuring from our baseline to go and figure out how far along this line and how far over on this line. Let's say we do it now 500 feet up. All right. And this is now, instead of being 100 feet to the right, we want it to be 100 feet to the left on here. And note what happens here. It now is 100 feet there. Now let's go and let's see if we can build this a little bit more. Our next point is 400 feet up, which means we're going to come back 100 feet, and it's going to be 100 feet to the left. So again, this is the final tool we're going to look at today. And it really uses the geometry of an existing line to go and calculate where along that line you use the baselines. I know I do have one comment. When you move a feature, you can change the snap point by pressing Control. Correct. Could we do that with the mirror tool? Let's try that. All right, and we'll finish off with that. All right, so let's go ahead and create this. By the way, it doesn't do anything until we actually hit create on the offset tool. Let's go and create a line. Just a simple line here. And then we'll use the mirror tool to go and mirror this. So, sorry, here, the mirror tool. And if we tell it with one click, we can't really click. If we do it with two clicks, it's actually here and here. Can we use the control click on this? I don't think so. I don't think we have that same luxury. I think we almost have to do it beforehand. I don't think we can control click on this to reset this for this, either with the two clicks or with the one click on here. I don't see how right away you can do that. So anyway, let's go back here. Sorry about that. So we've gone through all of these. If we look back, we went through parallel, went through perpendicular, deflection, again with Kogos. Segmented deflection allows you to create a multi-line or a polyline. Distance constraint, circular curves, spiral curves. And then we also looked at sort of how constructing things, copy parallel, extend trim, continue features, what it actually was doing there, what the line intersect does, and how it's different from extend trim, the fillet tool, the array tool, the mirror tool, and the offset tool. Just want to become comfortable with the tools that are in your toolbox. Esri has done a really great job of building these and putting these in here. And once you get to learn them, you can move up and you can understand how to go and combine them into different groupings and make it much more efficient in what you're doing. Are there any questions right now on what we've got? If not, thank you. And hopefully you learned something here.